Happy Thursday. We are going to continue with our trig ratios today. And honestly, what we're going to do today is kind of just like one more day of practice before we move on to like the really, really important stuff. Most of us got 10 and 11 correct on our homework, so I just went ahead and worked those out for you here. So you should have found that the adjacent side was 7. And then here are your two final answers. 24/7. I think there was only one person. I'm looking at it right now. Let's see. Yes, two people that did not get that correct. Okay, so that's really great that most of us got that. And then here's the second one, 7/25. Okay. Now 12 through 16, we're kind of all over the place, and it's because of finding this hypotenuse. Oh, I left it right there. I shouldn't have done that. I went ahead and worked it out and then decided I probably should talk about it. So let's talk about the Pythagorean theorem here, and then we'll kind of go through the answers, and then we'll just do a few more practice problems together or with me, and then I'm going to have you do a few more practice on your own, okay? All right, so it says, what is the sine of m? So I think everybody's okay with, I gave you tangent of m, so that's your O over your A. So they're placed where they should go. Now, if you put your m up here and your n down here, do y'all agree these would switch? Okay, so if your picture doesn't look like mine, that doesn't necessarily mean it's wrong. It just means it might be drawn differently, okay? But regardless, we have to do Pythagorean theorem to find the hypotenuse. All right, so when you do root 3 squared, that's root 3 times root 3, and we've learned that a root times itself gives you that number without the root. Okay, so root 3 squared, these two cancel each other out, so it's just 3. And then 2 squared is 4. Now, some of you left it as 7 and put 7 here, but that's incorrect because it's c squared, and so remember, to finish the Pythagorean theorem, we have to take the square root. And then square root 7 should be your final answer for the hypotenuse because you have to take the square root and it does not simplify. Okay, so now I can label my sides. This is my H. According to M, this is my O, and this is my A. Okay, and so now I can write down the answers. So it says, what is the sine of M? So the sine is O over H. I'll write it down here if you need me to. So Toa. All right, so sine is so. I've had a lot of practice, so this comes pretty quickly to me, but I understand some of us will need to look at this, and it'll come quickly to you over time. All right, so sine is O, so our O is root 3, and our H is root 7. Now, we haven't seen this exactly like this, so we should not leave it like this, all right, because the root 7 is in the denominator, which is a no-no. So as we've learned, you're going to times by root 7. Now, here's where it's slightly different from what we've seen before. Do you see that both of these are radicals? So we can multiply them together. So it will be root 21 over 7, all right? And then root 21 does not simplify because only 7 times 3, and neither of those are perfect squares. So that's your final answer. All right, now what's the cosine of m? So cosine is adjacent over hypotenuse, right here. So our adjacent is the whole number 2, and our hypotenuse is root 7. So then we're going to times by root 7 on numerator and denominator. And so our final answer should be 2 root 7 over 7. Now, if I'm looking back at your form really quickly. So number 12, the answers were kind of all over the place. I get that. I think only 5 of us got that answer correct. Number 13, yeah, that was better, but some of us still missed it because we called this plain 7 instead of root 7. So that's why you missed all of them. Don't necessarily think you did it all wrong. It just obviously throws everything off if you have that hypotenuse incorrect. Okay, so now it's talking about, see how we were talking about M here? Now we're going to talk about N. So what does that mean we need to move? It means we need to move our theta, right? So now we're going to move our theta from M to N. Now what does that change? It changes our O and our A. So now our O is here and our A is here. They just switch places, okay? The hypotenuse obviously never changes. It's always in that spot. So now we're going to do sine is O over H. So our O is 2 over root 7. And we just did that problem. So our answer is 2 root 7 over 7. So these two are the same answer. Exactly the same. Okay? Cosine is A over H. And that's root 3 over root 7, which that's the one we did at the top. So we're going to do root 21 over 7, and that does not simplify, so we'll leave it like that. And then these two are the same, okay? And then our tangent is O over A because of here. So our O is 2, and our A is root 3, and then we need to times. So that's 2 root 3 over 3, okay? Now, notice what we talked about yesterday, that the tangent of one angle and the tangent of the others will be reciprocals of each other. Now, don't look at the simplified answer, but look at this answer here and look at the one you had originally. You see how they're reciprocals? So that'll be every time. But obviously, we want the most simplified answer. So 2 root 3 over 3 is the best answer. And let's see what most of us put on 16. Yeah, that one was okay. Not bad at all. All right, so the big thing I want y'all to kind of practice or notice as we work today is that the sine of one angle and the cosine of the other angle will always be equal to each other, okay? And then vice versa. The cosine of one and the sine of the other will always be equal to each other. So, like, if you know that shortcut, you don't even have to do the work, really. You can just, like, copy the answer, okay? Shortcuts are always nice if we can notice those patterns in math, you know? Okay, so we're going to do just a few more practice problems, and then you're going to work a few. Okay, so this says, find the exact value of the three trig functions for the triangle below. So I've already put theta here, so I'm going to go ahead and label. Let's use a different color. That doesn't show up well. All right, so this is our H, this is our O, and then our A is the remaining side. All right, so sine, let's go ahead and write SOHCAHTOA up here. CAHTOA. All right, so sine is O over H, so our O over our H is that. Okay, now we have a no-no here, so we need to times by root 2. And so we'll have 7 root 2 over 7 times 2. Yikes, I'm running out of room. And so then I'm going to have to go down here, sorry. So that'll be 7 root 2 over 14. And then this can simplify. So the point of this problem is to show you, always remember to check yourself, okay? So root 2 over 2, because the 7 and the 14 can both be divided by 7, okay? All right, cosine is adjacent over hypotenuse, so adjacent over hypotenuse. And what do you know? It's the same exact thing. So I don't know if anybody noticed this from the get-go, but do y'all see that it's 7, 7, 7 root 2. So what did we learn before spring break? This automatically means it's an isosceles triangle. So it's 45, 45, 90 triangle. Just FYI. All right, so I'm not going to work this problem again. Why do the work when it's already done below? So root 2 over 2. Okay, is going to be that same answer because it's isosceles. So the sine and the cosine will be the same. And then tangent is O over A. And that simplifies. What does 7 over 7 equal? It equals 1. So our fraction actually simplifies to no fraction at all. It's just a whole number. And that's okay, but because we want it to be completely simplified. All right, let's move on to the next ones. It says sketch the triangle. All right, so let's do that. And then it says find the other two trig functions. So I'm giving you cosine in this problem. So we need to find sine and tangent, okay? And then in this one, I'm giving you tangent, so I need to find sine and cosine. All right, I'm going to go turn the monitor down. You can hear my son in the background, sorry. Okay, so let's draw this triangle. So cosine, all right, so here's where you have freedom to put theta here, or you could put it there, either one. You know me, creature of habit, I tend to always put it in the bottom. All right, so the 3 and the 4 are going to go in certain places. We have to know where to put them. So cosine is adjacent. Here, let me go. There we go. So cosine is adjacent over hypotenuse. So our adjacent is here and our hypotenuse is here. Okay? So in order to find sine and tangent, we need this opposite side. So what do we do to find that? Pythagorean theorem. All right, so we're going to do a squared plus 3 squared equals 4 squared. Alrighty, and now don't forget to square root it. So this one is root 7. And let's label these sides. That's bad practice I'm getting into. So this is our O side, this is our hypotenuse, and this is our adjacent. Okay? And so now we should be able to answer the questions. So sine of theta equals, all right, so sine, go up here, is O over H, so root 7 over 4. And is that simplified all the way? That's all you need to ask yourself. And the answer is yes, because a root on the numerator is totally fine and nothing else can simplify. So yay, that was easy. And then tangent of theta is O over A. So our O is root 7 and our A is 3. Woohoo, those were pretty straightforward ones. We didn't have to do any extra simplifying. Okay. All right, so let's go on to number 2. Number 2 looks a little weird because tangent is O over A, right? So this is the O side, the 6, but what's the A side, right? We have to have a fraction. So what have we learned? I think y'all know, you're probably saying it out loud or in your heads. We need to put an imaginary 1 under here, because isn't 6 over 1 still simplifying to 6? So it doesn't alter the answer. It just puts it in a form in which we can, you know, use it to draw our picture. Okay, so let's do that. So now we can draw a right triangle. Let's put theta here. So our O side would go here and our adjacent side would go here. And let's label those O and A. Okay, so now we need to do Pythagorean theorem. A squared, oops, we don't need to put A in, we have our A and our B. So 6 squared plus 1 squared. So do y'all see how the Pythagorean theorem was different from 1 that we just previously did in 2? 1, I gave you the hypotenuse, so you had to do some subtraction. But here in number 2, I did not give you the hypotenuse, so you're having to just do it regular, straightforward. So 36 plus 1, because 1 squared, a lot of students will accidentally put 2, but it's 1 times 1 times itself. Okay? And don't forget, the last step is to take that square root. And then you just ask yourselves, can that simplify? And the answer is no. So there we go. And that's our hypotenuse side. Okay? And so now we can finish our problem or our answers. All right, so we need to find sine of theta. So sine of theta is O over H. So our O side is 6, our H side is root 37. All right, sadly, we cannot leave it like that. So we need to times by root 37. And so our final answer should be 6 root 37 over 37. Remember the shortcut? No need to times 37 times 37. I don't even know that one off the top of my head. So we just go straight to our shortcut. All right. So there's that answer. And now we need to find, because it said find the other 2 trig functions. Since I was given tangent, we need to find sine and cosine. So now cosine of theta equals A over H. And then again, we can't leave it like that. So times by root 37. And so our final answer should be 1 root 37 over 37. And do we really need that 1? Nope. So let's erase it. If you put it, no big deal, but that looks better. Okay? All right. And now we're to the last 2. All right, it says find the sine and cosine of the acute angles. So remember, the acute angles, basically, acute means less than 90. So the acute angles are A and B. They're both going to be acute because the sum of them has to equal 90. So they're going to be less than 90 each. Okay? And it says, what do you notice about the measures? I hope you already know we should be noticing that the sine of A is going to be the same as the cosine of B. Remember how we said the sine of one and the cosine of the other, they should be equal. And then vice versa. The cosine of one and the sine of the other should be equal. All right, so let's put theta at A, because that's what we're talking about first here. And then let's label O, because it's across from, H, because it's across from, and then A. All right, so sine is O over H. So O is 6, H is 10. And now I hope you don't leave it like that, because that can simplify. 2 can go into both of them, so 3/5. Okay? All right, now the cosine at that same spot is A over H, so 8 over 10. That simplifies by 2, so 4/5. Now, I could just fill in the other ones, but I'm going to make sure that we understand, so I'm going to move my theta now and put theta at B, which then now this will be the O side, and this will be the A side. The H, of course, does not change. Okay? All right, so the sine is O over H. And notice they are the same. What I told you should be the same. And then the cosine of B is A over H, which is the same as the first one. Okay? So let's, it says, what do you notice about the measures? So the sine of A equals the cosine of B, and then the cosine of A equals the sine of B. Okay? All right, so it says find the sine and the cosine of the acute angles in the triangle. So it's literally the same thing that previous question just asked us to do. So we're going to find the sine of A and the cosine of A, and then we're going to find the sine of B and the cosine of B. But this time, I'm only going to do it once. We're not going to do the B's. We're just going to do the A's, okay? And then we'll just fill them in. You know, these two should be the same, and these two should be the same because sine goes with cosine, cosine goes with sine. Okay, so, oh, well, I notice here we only have the H and we have the A, so we need to find our opposite side doing Pythagorean theorem. All right, so I'm going to get my calculator. We're going to do 8 squared plus B squared equals 17 squared. And let's type in that 17 squared just so that we don't make any careless mistakes. 289. Now we need to subtract because we don't have both of the legs. And 289 minus 64 gives me 225. And let's square root. Now, you may not know, but 225 is a perfect square. So if we type it in, you should get B equals 15. Yay, no radicals to deal with. And that's our O. Okay. All right, so the sine at A is going to be 15 over 17. And because I know that one, I can go ahead and fill in this one. Okay. And then the cosine at A is the adjacent over the hypotenuse. And because I know the cosine of A, that means I know the sine at B is exactly the same thing. All right. So we practiced a lot of different things. I know it was kind of like redundant from yesterday, but we practiced a lot with radicals, with simplifying, and then the last thing I wanted to kind of hone in on is reminding you that the sine of one angle and the cosine of the other angle will always be equal. Okay? All right, that's where we're going to stop for today with the notes. And so here is your homework, all right? Your homework consists of problems 1 through 8. All right, so 1 through 6 goes with this picture here. It's kind of the easy one because it's already done for you. And then 7 and 8, you're going to draw the picture and find the other two, just like we did up here on 1 and 2. Okay? So if you need to kind of refresh your memory, just rewind the video and go back. But your homework is 1 through 8, and then we'll kind of get into the fun stuff tomorrow. All right, y'all have a good Thursday.